In this final lesson about digital certificates, we discuss how certificates are issued and how certificates are verified. When somebody makes a certificate request, there are two concerns to be addressed. Assume that Alice, our running example, she wants to make a certificate request from a CA, Certification Authority. From the side of CA, its concern is that it needs to check Alice's identity information to make sure that she really is Alice. And also, it needs to check whether Alice does really own the public key that she is claiming about. So one way to check is to ask Alice to prove that she knows the corresponding private key, because Alice should be the only one who has the private key, which corresponds to the claimed public key. From the side of Alice, to prove that she does have the corresponding private key, one way is to simply send both the public key and the private key information to the CA. But the thing is, even though CA is supposed to be a trusted authority, Alice wouldn't really want to disclose her private key, because in the context of asymmetric crypto system, private key are supposed to be private. She should be the only one who knows her own private key, nobody else. Before we proceed, notice the notation that we are using here. This notation refers to the public key of Alice, and this notation refers to the private key, the corresponding private key of Alice. And throughout the remaining slides, we will be using these same notations. Now, we discussed about the certificate issuing process, which addressed the two concerns that we discussed in the earlier slide. So Alice, when she makes a certificate request, she has to send these three information. The public key, her own public key. Of course, she has to send this public key because after all, she is trying to prove the ownership of this public key. What next is the signature. Signature that I'm talking about is she needs to sign over her public key using her corresponding private key. And if you think about it, this is in fact a way to prove that Alice does have the corresponding private key. So she has to sign over her public key. And I hope you still remember about digital signing process. This is the exact digital signing process that we discussed in our earlier lessons. And last, she has to provide her identity information, Alice. Of course, in the practical context, it could also, the identity information could also refer to the email address or the name of the organization which are trying to request the digital certificates. So they have to send all these three information to the certification authority. So when the CA receives this information, he has to check two things. First is, of course, he has to verify whether the identity information is valid. So this could involve the manual verification process. Okay, so that is the job of the central authority anyway. So they will make sure everything checks out, the identity information checks out. So next is the signature, digital signature verification process, because Alice has sent her signature to prove that she does own a public key. So the CA has to verify that. So essentially, the CA verifies Alice's signature by using Alice's public key, because she also sent a public key. So this is the exact digital signature verification process that we discussed in the earlier lecture. Again, notice the notation that we are using here. To denote the digital signature of Alice, we use this notation. So only if the signature is proved to be valid, that means Alice has proven that she does have the corresponding private key. That means the public key is really her own public key. So the CEO will be convinced that Alice knows the private key, because otherwise she wouldn't be able to generate the correct signature on the public key. So both of these checks have to be correct, the identity information and the digital signature verification. So if both of them are proved to be correct, the CA will issue a certificate for Alice's identity, Alice and her public key, together with the CA signature. So the certificate will contain these three assumption information and some other necessary information that I showed earlier in the earlier lessons. So mainly it will contain the identity information, the public key, and the CA signature. CA signature is necessary to make sure that this information cannot be tampered with. I repeat, CA's signature is necessary to to ensure that all this information cannot be modified, because this digital signature is signed over all this, the content of the certificate here, with the CA's own private key. So unless the third party has that private key, it is very hard to tamper with this information here. And all this information is known as the digital certificate of Alice. So after that, the CA will send back the certificate by encrypting it, so that it has confidentiality unless Alice decided to expose the certificate. She can keep, so that she can keep this certificate confidential. So the CA will send back the certificate, which may involve encryption. And how does the CA encrypt? Quite easily, the CA can encrypt the certificate by using Alice's own public key itself, so that Alice can use her own private key to decrypt the certificate information. So lastly, a certificate is in fact a binding between the entity, which is Alice here, and that entity's public key. So it is a binding. And that binding is enabled by using this signature. Okay, so that is the digital certificate issuing process. Next, we will discuss about the certificate verification process. When somebody wants to use a public key, then there has to be a certificate verification process to make sure that that somebody is having the authentic public key. Okay, so we will discuss about that in the next lesson.